Okay, this question 9 from winter 2022 paper. It is a reaction between PCl3 and chlorine to form PCl5. We are supposed to choose which pair of the statements which is correct. So, statement 1, we are supposed to find out if enthalpy change of reaction, which is this negative 124, is less negative than enthalpy change of formation of PCl5 or more negative. And statement number 2, we are supposed to find out if the Cl2 bond energy is needed in calculating the enthalpy change of reaction from enthalpies of formation. Now I'm going to go to the next slide. Okay, let me remove the statements, the answers, and leave a space here so that I can construct a hazard cycle to show how do we find enthalpy change of reaction from enthalpy changes of formation. Now, enthalpy change of formation means it is energy change when one mole of the compound is formed from its elements, okay, under standard conditions. So all these elements must be in their standard states under standard conditions. So we have phosphorus in solid form. I need 3 plus 2, 5 chlorine atoms here. So it's 5 over 2 Cl2. Okay, gas. Chlorine gas under standard condition. So state symbol is G. So these two elements will form PCl3 and of course Cl2, but Cl2 is an element, so the enthalpy change of formation is 0. And also to complete the cycle, this phosphorus and also chlorine will also form PCl5. Now, so for the first line, enthalpy change is delta HR here. Now, this energy change here will be enthalpy change of formation of PCl3. And for this elements to PCl5, the energy involved is enthalpy change of formation of PCl5. Now, the question tells us that both enthalpy change of formation of PCl5 and PCl3, they are exothermic. So they have negative values, okay? But before that, okay, let's find out how do we find enthalpy change of reaction from these two enthalpies of formation. So let me change the color. Okay, let's say blue. So now enthalpy change of reaction is going this direction. Okay, if I want to use a more indirect route, so it will be PCl5 plus Cl2 forming all the elements. Okay, and only form PCl5. So I need to change the sign of this enthalpy change of formation of PCl3, okay, in order to reverse this reaction. So delta HR, okay, the direct route is equals to delta H, negative delta H formation of PCl3. Okay. By adding a negative sign in front of enthalpy change of formation here, okay, I'm reversing this reaction. And then, okay, this one still the same direction as enthalpy change of formation of PCl5. So I'm still using the positive sign. Okay. Now, if you can remember, okay, the first statements that we are supposed to verify. Statement 1, enthalpy change of reaction is less negative or more negative than PCl5. Statement 2, the Cl2 bond energy is needed or not needed in calculating the enthalpy change of reaction from enthalpies of formation. Now, from the cycle that I've constructed, okay, you can see that um, I I did not put in any bond energy of Cl2 here for my calculation of delta HR. If you look at this, okay, there is no bond energy of Cl2 here. So Okay, for statement number two, okay, not needed. So the answer could be C or D. Okay, A and B says that the Cl2 is needed, so okay, we rule this two out. Now we are supposed to find out whether enthalpy change of reaction is less negative than delta HF, PCl5, or more negative. Okay, let's go back to this cycle. I'm going to put in I'm going to make up some values so that at the end I'll get negative 1, 2, 4. Okay. So let's say this is negative 24. Exothermic, right? They are both exothermic. So I put a negative value to represent that exothermic enthalpy change. Now this one, let's say I put negative 148. Because at the end, I'll get negative 124. Okay, you can put in any values, okay, as long as you can get negative 124 at the end by using this formula. So let me see, if I put negative 24 as enthalpy change of formation of PCl3, it will be negative 24, okay, plus negative 148, which is the enthalpy change of formation of PCl5. Sorry. Okay, let me erase this. Okay, and rewrite. Right. If so, at the end, I get negative 1, 2, 4. In order to get this negative 1, 2, 4, okay, can you see that the enthalpy change of formation of PCl3 should be less negative than the enthalpy change of formation of PCl5, right? Okay. And but we are supposed to compare these two values. Okay. We are supposed to compare these two values. Which is more negative? Enthalpy change of delta HR or enthalpy change of formation of PCl5. Okay, negative 124 is definitely less, okay, less negative than negative 148. So delta HR, okay, is less negative than delta HF formation of PCl5. So let's go back to the previous slide to look at the answers. We have C and D. For C, delta HR, the enthalpy change of reaction is less negative. Okay, D, the H reaction is more negative. Okay, the answer should be less negative. So C is the answer.